So a quick about ClearCalcs.com. You guys know we got to do it. So ClearCalcs is a cloud-based structural engineering or structural calculations platform looking to combine powerful FEA analysis with easy-to-use tools such as tools for wood, steel, cold form steel, concrete. Looking to be more accurate. So more accurate by means of validation examples, being fully transparent in our designs. We do not want to be black box at all. We want to eliminate wasted time. I'd say the number one feature to eliminate wasted time that I've heard from users is our load linking or dynamic load path tracking feature. So if you're a current trialist or if you're a current paying customer and you haven't used that one yet, highly recommend that. And then lastly here, available everywhere. If you guys know ClearCalcs, you know it is a cloud-based structural calculations platform. So home, office, site, coffee shop, you'll have access to your files. All right, so who is presenting today? Who's this guy? I am Connor, our Director of Customer Success. So I'm here to make sure you're successful in ClearCalcs, whether that be scheduling training sessions with me before you sign up, scheduling training sessions with me after you sign up, or maybe just sending you relevant help content that hopefully will help you along the way. That's what I'm here for. We've also got Addie, so kind to join us from Perth, Australia right now, which is crazy because it's 1 a.m. right there. I know I would be fast asleep, but thanks for joining, Addie. She is our head growth marketer, so making sure webinars like this and all of their help content is effectively planned. And another big shout out to Addie. We're kind of at the point where we're pushing these out almost every week. So that's really awesome to see we're able to create this content on a regular basis for you guys. Last slide here before we kick into it. If you guys are unfamiliar with Zoom and you have any questions along the way, feel free to tap that chat box and send any questions you have. You could send those directly to me, or you could send them to everybody. We will make sure to address these questions at the back half or the back end of the webinar during the 15-minute Q&A. And then if you guys have been with us before, you'll see, or we might ask you guys to unmute yourself to ask your questions live. So be sure to ask any and all questions that you guys have. Keeps clicking out. There we go. So what will we be talking about today? So today we're going to be talking column design in the real world. So this is kind of the third session of a structural design basics webinar series, where we're looking at the drawings from a beautiful Taos, New Mexico home. Today, we're going to stay wood focused on the columns. That's for no reason in particular other than the other materials are going to follow the same procedure. And what I really wanted to focus on wasn't necessarily materials, but the load application. Big piece of feedback we got from the beam design webinar was lateral loads. So how do we incorporate wind loads and seismic loads into our design? So for today, I figured that would be my main focus. You'll see we're going to run through 3 examples. The first example is going to be just simple gravity loads. So we're only going to be focusing on gravity loads in example 1. Example 2 is going to be a similar example, but we're going to add wind loads in there. So for everybody who is asking for lateral, that'll be a great example. And then this third one here, the seismic loads, that's going to be a bit more of a unique example where it might not be used or it won't be using our column preset. But what I thought would be a great opportunity is to show the portal frame calculator and how we could link one of the legs or one of the columns of that to a design calculator and do that that design per seismic. So hopefully that helps everybody. So let's kick into it. So for example 1, we're looking at just gravity loads, like I mentioned. I also mentioned this at the beginning, but if you guys have been here for the past few webinars that I've been leading, we've been looking at design drawings from this beautiful mountain home in Taos, New Mexico. For the beam design a month ago, we were focusing on this, this deck in the drawings. So just for the sake of completeness, I'm going to continue with that section of the drawings. And we're going to design for this first one and the second one, the post in the top right here. You see, I just pointed an arrow. I just brought in the screenshot there to avoid back and forth to the drawings. And then finally here, this isn't the actual deck. I just pulled this picture from decks.com just to have a visual. This will be more applicable for example 2, but we are going to just assume fully enclosed, that our deck is fully enclosed at the bottom. I know looking at that picture, you might say, we could say that's partially enclosed, just for the sake of example, and we'll touch on that in example 2, that it is fully enclosed for our sake. All right, so for example 1, gravity loads, here's our given information from the drawings. Again, I just screenshotted it and put in some dimension information so that we don't have to do any back and forth between the spreadsheet and the slideshow, ClearCalcs, and the drawings. So we're going to say here that we have a column height or a deck height of 10 feet. This is just an assumption because the drawings didn't have elevations when I received them, so we're going to assume 10 feet. We're going to assume that our column is continuously braced. Really, my only reason for adding that given is just to show how you can modify that in ClearCalcs. We're going to assume our support locations are just at the bottom and the top of our column. Again, pretty simple example for this first one. Fourth here, we're going to assume an axial eccentricity of our load of 1/6 the depth of the member. Again, my reason for putting that in is just to show you guys how you can modify that in ClearCalcs if you ever want to add an eccentricity. And then we'll take dead snow live load for our deck at 20, 40, and 60 PSF respectively. So now that we have our given information, let's go back and I'll exit out here. First thing we want to do is just come to clearcalcs.com. And we'll log into our account. I'm zoomed in enough, I think, here. And let's go ahead and create a new project. We'll just call this one Column Design Webinar. Throw in a random project number. And then because we like to be cheesy, I'll say the client is an efficient designer. Just because we know this is in Taos, New Mexico, let's just find a random Taos, New Mexico address here. So I just picked the first one there, right next to a weed and coffee shop, it looks like. So I guess if you know where to go if you're ever going to Taos, New Mexico. So lastly here on this page, I just want to point this out for anybody who is watching the recording after the fact. I need to change mine to Imperial only because I'm on the ClearCalcs account, which is Australia. So mine is defaulting to metric. You guys, you'll be fine. It will default to Imperial there, but just didn't want to have any confusion there. So what we'll do here, now that we got our project details set up, I clicked Add New Calculation. Let's go ahead and click on Wood Column. For anybody unfamiliar with ClearCalcs, we do have both ASD and LRFD design methods and design calculators. From your point of view as a user, they're going to function the exact same way. Just pointing that out because for today, I'm going to use ASD because the more I talk to users, it seems like if you're doing wood, you're doing ASD. So that just seems to make most sense. I'm going to click on the exposed outdoor isolated column here. I'm going to click on that preset. For reference here in ClearCalcs, if you clicked on any of the other presets, even the generic beam or anything, it's going to function the same way. What this exposed outdoor is just going to do is modify some default inputs, say that it's wet conditions and things like that, because we already know it's outside. So let's just call this example 1, deck, if I can type, deck post, geez, there we go. All right. So here in ClearCalcs, again, most of you are familiar, I think, but inputs on the left, outputs on the right. And for now, let's go ahead and input our given information here. Pop them back into our slideshow here. We know we have a column height of 10 feet, and we know our column is continuously braced. And I'll do a few at a time here. So let's scroll down into column height, which is 10 feet. And then we could see there are 3 different toggles here for strong axis buckling, weak axis buckling, and lateral torsional buckling. You could see that ClearCalcs is defaulting these to no continuous bracing because that's the more conservative state. But in our case, we know we want to toggle these on to yes. So again, you'll see my reason for just putting that in the given information was to show you how you could swap those toggles. Next, we know we have a pretty simple support condition here, just supports at the bottom and at the top. So if I scroll down here to our supports, we could see that ClearCalcs is defaulting to a pin support at 0 and a roller support at 10. Now, if we did have, for example, any intermediate bracing that we wanted to add and we didn't have this continuous bracing that we toggled on, easy as just clicking this drop down in the 3rd or blue row there. You see we can add a weak axis brace, a strong axis brace, or a lateral brace. So for example, let's say this isn't our example, but we wanted a strong axis brace halfway up, or the full length of the column divided by 2. We could see that ClearCalcs has now just added this strong axis brace at 5 feet there. But for our example, we don't have that. So I'm just going to remove that. Just wanted to show you guys how you could add that if needed. Next, we have our axial eccentricity of 1/6 the depth of member. Now, why did I put that? Because that is our default axial eccentricity here. If I click in here, you can see we're looking at depth of the member divided by 6, or D divided by 6. We can see as I clicked into our help accordion, or as we call it internally, our debug mode. We recommend if you're using axial eccentricity, a good place to start is you can take 1/6 the depth of the member. Nice thing here by leaving it as D over 6 is no matter what our selection is, what our cross section is for our column, this will automatically update based on the dimensions of our column. So that's another thing there, just showing you why I put that as a given in our information to show you how you can modify that. Next, probably the most important input is the load input. So we know we have a dead load, a snow load, and live load. And we are not doing wind loads in this first example. Again, we'll look at that in our second example. So the first thing I'm going to do is just remove these default wind loads for the strong axis and weak axis here. Again, only doing that because we're just considering gravity loads for this first example. And so now let's input our gravity loads. Let's start from scratch just to show you guys how you can do this. We'll say deck load 1, or just deck load, doesn't matter. Starts at L, or the full length of the column. What we're saying here is the load is applied at the top of the column. Our axial eccentricity is equal to this axial eccentricity we had up here. The reason you're seeing a different numerical value is just because this is 1.25 inches and this is 0.104 feet. You could see here that this input field is in feet, so just to avoid any confusion there. And then now we want to actually input our load magnitudes for dead, live, and snow. No lateral loads right now. What we want to do is input our Y direction axial loads, and it's asking for that in pounds. So what we need to do is come back into our given information. What we would likely do is look at the drawings, but this is why I screenshotted it and brought it in. to avoid the back and forth. But we need to determine what portion of these distributed loads are being passed on to this column or post in the top right. So as I'm sure many of you are aware, basically we just have a rectangle here for this deck. We've got supports columns at each end. And for lack of a better term, we can essentially visualize that there's 4 different quadrants here, where the distributed load from this top right quadrant, is what's being passed on. If I didn't mess up in this, and we're back, is what's being passed on into our top right column here. So the reason I show these dimensions is because this tributary area of 12 feet by 5 feet is what's going to be applied to our top right post that we're designing. So to show you how you'd input that into ClearCalcs, recall we have a dead load of 20 PSF. We could do 20 PSF times 12 feet times 5 feet. And so now we're saying of that 20 PSF dead load on our deck, 1,200 pounds is being passed down onto our post that we're designing right now. And now we could just copy that through because it's the same tributary area. And let's just modify these distributed loads. If you recall, the live was 60 PSF. The snow was 40 PSF. And so just like that, we have our 3 dead live snow loads applied to our column. For example 1, that's the only inputs that we need to put in. And now what we could do is scroll up to our member selector and actually select a member that's going to pass or that we're comfortable with. Just to avoid any confusion, we could see from the screenshot here, the designer did choose a 10 by 10. A few comments there. 1, we're only considering gravity loads in this example. Also keep in mind there might be another spot in this home where there was a more critical column and they just used it as that 10 by 10 for everything. Reason for saying that is because, as you'll probably notice, we're going to end up with a much smaller post than 10 by 10. Let's click select. It's already filtering down to post and timber. Let's say all I want to see is dug for large number 1s. And now we can see side by side which column dimensions work here. So it looks like the smallest one of the post and timber is the 5 by 5, which works. Just because I think this is a little more common, I'm just going to click the 6 by 6, because why not? But no, of course, that 5 by 5 works, and probably some smaller dimensions as well. So for this first example, we can see we now pass with a 6 by 6 dug for larch number 1 at 31% utilization. And as I hover over that, the controlling factor is the combined compression and bending. So basically the combined compression and bending check is the most critical check with our current setup. So that's about it for the first example. I'm curious if there's any questions so far. Happy to run through those. Otherwise, I'm more than happy to pop onto example 2, where we're going to start to talk more lateral loads. All right. Crickets. Perfect. All right. So let's move on to example 2 here. So like I mentioned at the beginning, we're going to be looking at gravity and wind. For simplicity's sake, I just said, let's do the same example. Let's keep the geometry and the gravity loads the same. So you would work through the same process there. And what we're adding here is this wind data. Now I pulled this wind data from the drawings, again, just to avoid any back and forth. So we have a wind speed of 115 miles per hour and an exposure category of C. Again, shout out dex.com for I pulled this picture from there. We're gonna assume that it's fully enclosed, even though you might be able to say this is partially enclosed. This was just the quickest, best picture of an enclosed deck I could find before this webinar. So what we're gonna do for this design is I'm gonna come back into ClearCalcs. First thing I'm gonna do is, if you guys see this duplicate button in the top right, I'm gonna click that. And what that does is create an exact copy of the column that we just designed in ClearCalcs. My reason for doing that is because I don't want to have to start from scratch and re-input all of that geometry information, the loading information. Now that I've got it already set up and duplicated, all we need to worry about is the lateral loads. So what we're going to do here is click Add New Calculation. And we're going to say that the this column that we're designing is a component of the overall system. My reason for saying that is we're going to click on the Components and Cladding Wind Load Calculator here in ClearCalcs. So we'll say example to CNC. For reference, you guys don't have to change the names of the calculators. I just like to stay organized. You see we're referring to ASCE 716 here. And now we're going to start inputting our information from the given. We had 115 miles per hour wind speed. We had our exposure category of C. And then next, for these effective roof and wall member wind areas, I'm going to leave them to 1 foot squared, only because that's the most conservative estimate. And I just want to, as a designer, save myself all the time I can. So I'm going to leave those as 1 foot squared. Next, let's come into our building or deck properties. Let's say we're flat. Let's say that column height or the roof height, deck height was 10 feet. And then we were 10 feet by 24 feet. If you guys remember, just so you guys know I'm not lying, we're 24 feet along the top, 10 feet, I guess, in width, and then it's 10 feet high. That was our assumption. The last few inputs here, just for completion's sake, we give you the option, do you want ClearCalcs to automatically determine the ground elevation? So you can see this ground elevation above sea level is actually being automatically pulled in from our Taos, New Mexico address. So we're at about, looks like just under 7,000 feet there. So pretty high next to the cannabis shop there, cannabis and coffee. They're getting a free plug, I guess. And then lastly here, the hill and escarpment. Do we have a hill or escarpment present? I'm gonna say no, but if you did, easy as just toggling that onto yes, and you could put in that information here. So we'll leave that to no. And now we can see, as with other ClearCalcs calculators, our outputs are on the right. I think it'll help if I zoom in one for this. So what we want to do is, most likely our worst case wind load is at this 5, between the 4 and 5, or location 5, because of our post. So let's check and just make sure that 4 isn't worse than that. But that's the wind load down here that we're going to be using. All right, so we could see at zone 5, we have 27.6 PSF positive wind pressure and negative 34.4 PSF negative wind pressure. So that's how we'd take our miles per hour data, our general building or deck geometry, input it into this components and cladding calculator, and turn it from miles per hour to PSF. And this is the information that we want to input as the lateral loads now into our deck post. So let's pop back into our deck post. I'm going to zoom out one. Scroll down into our load inputs that, remember, we already have our gravity input there. Let's come back in here to this slideshow. I keep forgetting the word slideshow and want to say spreadsheet, but come back into this slideshow. And just as a visual, so we are designing this top right post. What we want to do is apply, or what I'm going to do is apply a wind load from the top. If you can imagine, coming top down onto our post, and then also coming from the side. So my reason for saying that is for this first one, we're going to assume this is the wind load coming from the top. And it's got a tributary width of our enclosed section of 12 feet. So that's our trib width on this first side. So we've got wind load 1 going from 0 to L, meaning it's starting at the bottom of our post and going up to the top, the full length of our post. Our tributary width here, half the distance to the next support, was 12 feet. And now we just need to input those load magnitudes. So just because I already forgot those, let's come back in here. 27.6, negative 34.4. So 27.6, negative 34.4. All right, so we have those inputs here, 27.6 and negative 34.4 PSF. And we can see now that wind load 1 is being applied lateral distributed load to our post. The last input we want to put in, coming back to our drawing here, the screenshot from the drawing, is the wind load coming from the side. So we want to check that same wind load, but now with a tributary width of 5 feet at the weak axis. What we can do is expand. Yep.
Hey, sorry to interrupt. It's Enrique. Well, I'm sure you can see my name here on the screen.
Yep.
I just wanted to check those CNC wind loads that you're inputting. Those are ultimate wind speeds, ultimate wind loads, and then you're inputting them into an ASD calculation, I take it?
Yes, I believe so. You know what? Let me confirm that with the engineers for you.
Okay, and then I figured the ASD load combinations will, apply the 0.6 W, the 0.6 wind load factor, and kind of take it down to ASD pressures, if you will. But I just wanted to make sure that the CNC outputs were ultimate, not service or ASD.
No, that's a great question. I believe so, but let me confirm with the engineers after this webinar, and I could, we'll shoot an email to everybody, just making sure that I'm not putting my foot in my mouth.
Thanks, Connor.
Addie, would you mind taking a note on that question? Thank you.
Would do.
Appreciate it. Good question there. Where was I? So the weak axis loads, you guys can see the weak axis loads by default is minimized here. So all I need to do is click on that. And that's going to bring up the load inputs for weak axis. And now for lateral distributed loads about the y-axis, let's just put in our wind load 2. Again, from 0 to capital L, or the full length. In this case, we want a trib width of 5 feet. And then 27.6, negative 34.4. All right. And now we can see, now that we've put in those wind loads acting on 2 axes, so biaxial loading there, this 6x6 Doug fir larch number 1 that we selected in our first example is just at almost perfect at 100%. Probably we want to upsize a bit just to be a bit more confident, but we can see that the combined compression and bending is at 100% utilized. So in this case, all we need to do is pop back into our member selector. We can see because we duplicated this sheet, it just held on to my filters that I already put in place. So we could bump up. The 5x5 doesn't work. 6x8 looks like it works. Just to be OCD and keep it even here, we'll go 8x8. But the 6x8 did work. So we can see now with the gravity loads and the lateral wind loads here, we are at 40% utilized. Again, that combined compression and bending being the highest or maximum or most critical value there. All right, so that is example 2. Great question, Enrique. Were there any other questions that had come through that we want to touch on before going into example 3?
There are 2 notes in the chat, Connor, that ask about load combination and bracing.
So the load combination, that's a good question. I think that kind of touches on Enrique's question as well. One thing you guys can do, so I guess to start, take a step back. These percentages on the right-hand side, ClearCalcs is always taking the worst case load combination. If you guys go up and expand, I guess, this header window tab, you can modify between standard and detailed mode. If you click detailed, you'll see what that does is it's going to give you the governing load combination for each of these checks. So it looks like, for example, the governing load combination for combined compression and bending is the 0.6D plus 0.6 wind up. This is why I'm fairly positive, Enrique, to your point, it is pulling out the ultimate and then it's factoring it in within this question. But to be honest, that's the first time I personally got the question, so I want to make sure I get you the right answer. And then you mentioned, Addie, another question was around bracing.
Yes, just a comment from Christian that bracing is coming in the portion of the presentation here. If you want to confirm on that.
Yeah, so I guess I touched on it in our first example, but let me know if you have any further questions. What you can do is modify the bracing within your calculator here, whether it's continuous bracing for strong axis, weak axis, or lateral torsional buckling. So we can see we can modify these to no if we'd like. It looks like it makes a pretty small impact here on the Y compression. Bumps it up to 12%. Another thing you can do is in the support inputs, instead of just having this simply supported column, we can add a weak axis, strong axis, or lateral brace. And that way we can see, you know, what impact that has on our overall design. Does that answer the question there?
Yeah, I am just sending Christian, if you want to add more comments in the chat, if we address your question, or feel free to jump in and talk to us here.
Yeah, definitely. And then Christian as well, if you're unable to unmute and join in, completely fine. Send a question. You can either send it to me directly if you need further context, or just a good opportunity to show this, I guess, this help button in the bottom right. If you guys click that, you'll see you'll have articles related to the calculator you're currently in, but you could also click ask at the top. And this way we could send, you know, any questions that we have, and this goes directly to me. I get these, and then one of our internal structural engineers, 6 days a week, we relieve them of all their other duties, as I'm sure most of you guys know, and they just respond to those questions. All right. Yeah, so definitely send questions through. especially after the webinar, if you guys have any. So for this last example, I'll move on to example 3, just looking at the time. This one's going to be a bit more unique than the 2 column examples that we just ran. My reason for doing this is because one, just based on questions from last webinar, I thought it would be good to run through the seismic analysis calculator. And then 2, even if you're in a zone or a part of the country that you don't really deal with seismic, we'll apply those seismic loads to our frame calculator, so we can see how we can do a frame analysis, and then similar to what you can do with the trusses, if any of you guys were there a few weeks back, you could link that to a design calculator. The one caveat I'll say, because I'm sure questions will come through on it, are the connections of the frame. I know that especially of a wood frame, the connections are a whole nother animal. That is not something that can currently be done in ClearCalcs, so I won't be touching on that. Just figured I'd say that because I'm sure questions will come through regarding the connections if we're doing a frame. But for this one, like I said, a bit more unique. We're going to assume not that it's a component of our overall building, but we're going to assume that this deck or this post is part of a freestanding seismic resisting frame. We're going to say our leg height or column height, similar to before, is 10 feet. And we're going to say our frame width here across the top is 24 feet. And then we have the rest of our seismic data here. So I pulled all this seismic data from the drawings. But what you could do if you guys are unfamiliar with, where do I find the short period spectral acceleration and long period spectral acceleration, all that fun stuff. What you can do is, maybe I'll bring it on this screen and then bring one over because the zoom controls are in my way. You can search the ATC hazards by location tool. I'm sure some of you are familiar with this, but wanted to point it out. This is a free tool. Zoom in a little. You can input your exact address, and then you can get the wind, snow, tornado, and seismic data at that exact location. So let's use a real address. If you guys have been in a demo with me, you've probably seen me use this one, just a common one. But let's say at the White House here, we can gather this wind data, any snow data, newly added the tornado data, and then also for seismic, we just need to input 2 more inputs so that we can get correct information. I'm sure the White House is different than this, but I'm going to use our inputs for this just to show you guys how we do it. So we'll say like risk category 2. Whoops. Oh no, the zoom controls are in my way. There we go. Risk category, we'll say 2. Site class, ours was D. So of course you'd have to figure out that information to input that into ATC hazards tool. But you could see on the left-hand side here, we're getting all that information that I've put as a given in our problem. Yeah, so definitely use that tool. It's a free tool, very exciting. Hopefully one day we'll bring those automations into ClearCalcs. We have been talking about that, but for now, I think this is a great tool. Get it in the way where I can use my tools. Okay, so first thing we're gonna do here, we're gonna come into ClearCalcs and we are gonna open up our seismic analysis calculator. So what I did there was just click create new calculation. Scroll down into this seismic analysis. And again, don't have to change the name, but I just like to. Example 3 seismic. And now let's input our given information that either we gathered from the drawings or we use that ATC hazards tool to get. We'll say our short period spectral acceleration is a mouthful, but I'll just copy paste that in here. Our long period spectral acceleration. We'll copy paste that as well. And then our long period transition period that you would have gathered from that tool. We can input that information in. And now we have our last few inputs here. So I say building risk category of 2. That's currently the only building risk category that the Seismic calculator works with in this first version. Story height of 10 feet. And then we have an effective seismic weight of 50,000 pounds or 50 kips. For that one, if I'm being honest with you guys, I just made that one up for the sake of example, but that's something that you'd have to determine as the designer. We can expand into our help accordion or debug mode to get some additional information. For example, per ASCE 716, seismic weight shall include dead load as defined in section 3.1, and so on. That's why we put these debug mode or help accordions in for you guys. So if there's any inputs that you're unfamiliar with, just go ahead and expand it and we'll give you some additional information. Just a quick side note on that, if there's any expanded views where you don't find it useful, you think we can add a bit in there, add some visuals, please let us know via that help button. That helps us out a ton. Our last few inputs here, we're not going to use custom building period or custom seismic force resisting system. You could see if I did toggle this onto yes, it'll ask me for the fundamental period of the building. And if I want to change to a custom seismic, we could input our values here as well. Last input here is the seismic force resisting system. Now, I want to say again, this is a very unique example. You most likely aren't designing, or maybe you are, designing this deck as its own seismic force resisting system. You might be, or as a frame. It's probably a component of the overall building, but for the sake of example, I'm saying that we're gonna. And for here, we're gonna say it's a timber frame because essentially that column that's coming up from the ground, we're gonna say it's like a cantilevered column that's gonna need to resist seismic forces. My reason for saying that is because you'll see our seismic base shear just increased significantly because we're saying that we essentially need to resist it just with this column or post of the frame. So it's pretty high. So there's that caveat there. But just for the sake of example, that's what I'm going with. So next, we want to, like I said, we want to design this as a frame and bring this seismic base shear into our frame calculation. So let's add a new calculation. We'll scroll down into the portal frame analysis wizard. So this is what's going to allow us to analyze the frame before we then link it to a design calculator. We'll call this example 3 frame. And now, first step, as always, is just input our geometry. So in ClearCalcs, again, inputs on the left are outputs that are going to update real time or on the right. Number of bays, we're going to leave to 1. You could see if I modified this to 2, it essentially just duplicates the bay on the right-hand side here. But we'll leave that as 1. Our width was 24 feet. Our leg height or column height was 10 feet. And if you need to, you can modify your outer leg properties. For example, maybe you have more of a triangular or trapezoidal shape here. But we're going to say that our deck is not on a slant. Everybody will be falling down. We're just going to leave it flat. And the next thing I'm going to do, if you guys were in our truss design webinar a few weeks back, this will be familiar. But what I'm going to do is skip past this member selection, and I'm going to input my loads first. My reason for doing that is because I want to set up my loads. I want to set everything up, and then I'm going to link it to a design calculator. So here's our distributed loads and point loads. For the sake of example, we're just going to consider those seismic loads. So I'm going to remove any of these inward loads or distributed gravity loads. And I'm just going to say my inward lateral point load at the top left is that large, again, very large, 12,300 pounds. So we could see on the top right here in our analysis outputs, we have 12,300 pounds being applied at the side here. And then we could toggle through to see the resulting bending moments, which are pretty high, the shear, the tension and compression, extensions, displacement, and our reactions as well at the bottom. And what I want to do is I just want to design, say, this left leg or this left member. To do that in ClearCalcs, again, same procedure if you guys were in the truss one, is I'm going to click Add New Calculation, scroll down into Design Only, click on the wood member because we're designing a wood member in this example. And I'm going to click Link to Analysis module. Let's just change the name, example 3 design, or I'll say example 3 left leg maybe. And what ClearCalcs has given me right here is an error saying you got to link something in here. You said you were going to link from a design or from an analysis calculator, so go ahead and do that. So we're going to link from example 3 frame. And then now what ClearCalcs allows me to do is I can select either the envelope, meaning the worst case of the left legs, right legs, or chords, or I can go individually and go left leg, chord, or right leg. Now, because we had such a simple frame setup, these are the same. There's really no difference, but you could imagine if you had a more complex frame, the envelope might save you a bit of time because that's just the worst case. So we're going to click on this one here. And as you guys probably imagine, with that massive load that we were resisting that seismic load with just this column, this 2x6 hem for number 2 does not work. But we can easily just click into our member selector. Let's again say we only want to do post and timber, we only want to do dug for larch, and we only want to do number 1. We can see in this specific example, we end up with a big one. We end up with a pretty big column here. Just to keep it even, I'm going to click this 18 by 18, big old column, dug for larch number 1. Now, the last thing, we did link our analysis module into our column design module here. But we can see it gives us this error. The member selected does not match the member in the analysis calculator. So the last thing we need to do is come back into our frame analysis and just make sure that left leg is equal. So I'll click on left leg. We'll just look for an 18 by 18 dug for larch number 1. And we could see that the example 3, the design, is recalculating here with this new analysis we're running. And we could just click back in and just confirm that we still pass. All right, we're still good to go at 83%. Now, I know that example was pretty unique. I'm not sure how often you're going to be designing, say, a deck with a seismic resisting frame, but figured that would be a great way to incorporate both seismic loads and using that frame analysis and design calculator. So That's about it. The last thing I really just wanted to touch on first, then we could hop into questions. Looks like we have about 10 minutes left. As I said that, 9 minutes left. Really quick, as of last webinar, last month, the what's new in ClearCalcs, we had IBC 2021 with all the new ACI 318-19 updates, CBC and FBC. And then since last webinar, the team has, or since the last webinar I hosted, I should say, we have wood truss and portal frame design, like I just showed you in the third example, main wind force resistance system calculator, snow load analysis, and we have added shear keys and retaining walls. And I'm looking forward to the next webinar where I can say we've added a lot more. But for the sake of time, figured we could jump into any questions that came through. I'm sure a few came in, possibly. Let's see here. All right. Oh, good call there, Matthew. ASCE has developed their own hazards tool and ATC will no longer be updated. Good call, good call. So yeah, if you guys could see the chat there from Matthew, check out that tool he brought in. How did I find the long period transition period value? So that, like I said, initially was brought in from, it was just on the, where are we at? Right here. On the drawings, but using the ATC hazards tool, which Matthew has pointed out, definitely make sure to see any new tools. You could see this long period transition period. And this was just for the White House, was 8 seconds. And that was for, yeah, risk category 2 and site class D. I just took the 6 from the drawing, so good question. Good question there, Christian. Thanks for sending that through, Addie. How can you see the trust webinar? That was a great one that if you guys know Laurent, he's our North American engineering content lead. He ran that webinar, I think 2 weeks ago. So definitely check that out. Addie posted that in the chats. Certifying these webinars. So Addie, correct me if I'm wrong, but people should be receiving an email and I think it goes out in 2 days with the PDHs or the certificate.
Yes, correct. We will be sending certificates as we understand that the requirement varies state by state in the US. So let us know if you have any further requirements to be able to claim this as professional development hours. Any organizations that you think we should be talking to, please send them through and we will work that into our webinar process.
Awesome, thank you, Steve. All right, I got a question from Monisha regarding our member selector and just modifying. So for example, coming to this deck post. So all I was doing, she was asking, can we change the species? So I had just filtered it down to Doug fir larch, but yeah, you can modify to spruce pine for, as you see, I think I'm still sharing my screen as well. Good question though. Thank you, Steve. Thank you. I appreciate it. And thanks, Christian. Yeah, we appreciate the kind words, guys. And then in addition, especially if you guys liked these webinars or we're running through different examples, you know, let us know types of examples you guys want to see, types of design in the real world, because yeah, we're constantly looking at adding new webinars in the future and keeping this flow going.
Also at Connor, if anyone have any design drawings that you want to share for us to run through the examples at our webinars, we would welcome that as well very much.
Yeah, 100%, because we're basically at the end of doing some of the examples from this specific mountain home design. So if you guys have any past work that you'd like to both showcase and use as some examples for ClearCalcs, we more than welcome that. Can you do built up posts? I'm not sure if this answers your question, but you can always modify the number of plies here. Thank you, Kelly, appreciate it. You can modify plies and then we can look down to, you know, maybe we could do 2 2x6s, for example. That was a random example, but that's how you might be able to modify that, Vikas. All right. Well, Enrique, I will get you the answer to your question. Anybody else? Oh, that's a good question, Matthew. Is ClearCalcs team working on developing an API to batch design members based on spreadsheet inputs? We are working on developing an API. I'm not sure exactly, to be honest, that's not something I'm intimately familiar with on what it's going to connect to, but I think based on my understanding of APIs, it'll allow us to connect to a lot of things. So yeah, definitely send a question about that into the help team so that way we can connect and discuss internally and let you know there, Matthew. And then, yeah, last thing here, and then we'll give you guys back a couple more minutes. Any questions after this? Maybe they pop up after we end this presentation. Use that help button. That's the best way to get a hold of me and the engineers. So that way we can get back to you within the day. And really appreciate everybody joining. Hopefully you guys found this useful and look forward to seeing you. I think we have one next Wednesday. We're going to be talking with Laurent and David Ortecan about heavy timber framing again. I know that got some positive feedback last time, so definitely show up if you guys are interested. All right, everybody. Well, enjoy the rest of your day. Addie, go to bed because it's 2 a.m. for you. And we'll see everybody.
Thanks everyone for joining.